In this question, we have to determine the admittance parameters y11 and y12. First, let us define them. Okay, I1 is equal to y11 v1 plus y12 v2. I2 equal to y21 v1 plus y22 v2, where y11 is equal to I1 by v1 when v2 is equal to 0, that is when the output is short circuited. Similarly, y22 is equal to I2 by v2 when v1 is equal to 0. First we will be considering the case when v2 is equal to 0 in order to determine y11. Okay, so now v2 is equal to 0. Okay, let us draw the circuit when there is a short circuit applied across v2. Okay, we have a 1 farad capacitor and then a resistor here 1 ohm, and then a capacitor here 2 farads. Okay, and then the resistor. Okay, now this is 2 dash 1 dash. Okay, this is v1, this is 1 farad. Okay, now we have, okay, before that this is 1 ohm. Now there is a short circuit here. Okay, now if we can observe clearly, okay, this resistor has no significance, that is this resistor and this capacitor are in parallel. Okay, so v1 is equal to, okay, while calculating v1 what we will do is we will take this current as I1. Okay, and first this 2 farad capacitor is in parallel with this 1 ohm resistor. Okay, and then that particular equivalent impedance is in series with this 1 farad capacitor. So v1 is equal to I1 into, okay, determining the equivalent impedance of this whole circuit, 3s plus 1 by s into 2s plus 1. So how do we get this? This is after simplification of all these resistors and capacitors impedance. Okay, so y11 is equal to, which is I1 by v1 is equal to s into 2s plus 1 by 3s plus 1. Okay, now we have determined y11. We have to determine y22. Okay, for that what we should do, we have to make v1 is equal to 0. So when we make v1 is equal to 0, okay, our circuit will look like this. See, there is a short circuit in the place of the voltage source which was initially present. No voltage source, in fact, in place of 1 dash. Okay, see, in 2-port networks there is no voltage source. We can assume it wherever we want to help us in calculating the parameters. 1 farad. So this is v2. Now we have to find y22. Okay, y22, which is equal to I2 by v2 when v1 is equal to 0. Right, now what we have to do is, same like the previous case, we have to determine the equivalent impedance of this whole branch. Okay, of this whole branch, a whole network in fact, and then we know v2 is equal to I2 into the impedance of the whole network. So when we calculate Z equivalent, okay, first this capacitor is in parallel with 1 ohm resistor, right? So that expression for impedance for that particular equivalent impedance is 1 by s into 1, which is 1 by s, divided by 1 plus 1 by s, and that is in series with the 2 farad capacitor, so plus 1 by 2s, and that again is in parallel with 1 ohm resistor, so that is in parallel with 1 ohm resistor. Correct. Now if we find the equivalent impedance, we will get it as 3s plus 1 by 2s square plus 5s plus 1. Okay, now what is y22? It is the inverse of it. Okay, 2s square plus 5s plus 1 divided by 3s plus 1. So the correct option in this case is D.